Right, we're told that ABC is an isosceles triangle such that BC and AB are equal, points X and Y lie on AC, and we're given AY and AC in terms of AX. And there's a diagram of the triangle which fits the facts of the first line. So I've put the 2 points X and Y on AC at arbitrary points. Again, the diagram could go wildly wrong and represent very different distances, but let's just guess they're there. Now, we're told that AY and AC are both in terms of AX. So AX effectively is the master. So I'm going to call AX distance X. Now I can put the values on that they suggest. AY, this is equal to 3x. Well, if that's true, this is 2x. Now let's look at the other fact. AC, the whole lot, is equal to 4 times AX. So this is 4x. Well, if there's 4 of them along the bottom here, this again must be x. So the diagram actually is not too bad at all. And we're now asked to prove that ABX, which is this sliver of a triangle here, is congruent with this sliver here. Well, the first fact that we can say is that AB equals AC. So that's a side relationship. This is another side relationship. And 3, can we prove that the other 2 sides, which is BX and BY? Well, yes, we can, because this distance AX is X and YC is X. We have perfect symmetry. So it must be true that this side equals this side. So writing that down, I can say that BX from the left-hand side triangle must equal BY, which is another side relationship. So therefore, triangles are congruent because we have an SSS relationship. And there's your proof.